Hey, what is up, you guys? So today we're looking at differentiation from first principles, right? Remember, we've just covered rules of differentiation, right? So alternatively, instead of using the rules, you can actually take the longer route, which is using first principles. So it's actually very important to know both, because sometimes they will specifically ask you to use first principles to differentiate, right? So yeah, you have to master the rules, and you also have to master how to differentiate using first principles. I mean, this is literally one of the easiest ways to, sort of like collect marks in grade 12, right? Why? Because this is so easy, okay? Super easy. So now let's get right into it, right? Let's get right into it. First principles. So what does it mean when they say we differentiating using first principles? So if you're given any function f of x, so f of x, let's suppose that f of x is equal to let's just say x cubed, all right? And then yeah, let's just keep it simple for now. F of x is equal to x cubed, and then we want to differentiate it using first principles. In fact, x cubed is going to come across as a bit, so let's just say x squared. All right, f of x equals to x squared, and we want to differentiate. So obviously, when you're using your differentiation rules, this has to be in standard form. In other words, f of x needs to be in the form of ax to the n, right? Ax to the n. And if you check, right, our a here is actually what? 1, and the n is 2. So a is equals to 1. And it's equals to 2. So we know by making use of the rules that dy over dx, which, because we know that we're dealing with function f, we can refer to as f prime of x, is going to be 2 times the 1, right? And then x to the exponent the 2 minus 1. So this becomes what? 2x. Okay, so this is what we're getting when we're using the rules of differentiation, but this is the exact same answer that we should get when we are using first principles. So let's talk about first principles. What does it mean when we say we're differentiating using first principles? It simply means that there's a different formula that you're using, which says f prime of x must be given by the limit when h approaches 0, right, of what? F of x plus h minus f of x divided by the h. So this is the formula for first principles, okay? This is the formula for first principles. So, meaning that, okay, now you need to figure out, okay, what is f of x plus h, okay? So, f of x plus h simply means that in place of x, you're going to substitute x plus h, okay? So, remember our function f of x is what? X squared, okay? It's x squared. So, in place of x, we substitute what? X plus h. This is f of x notation, so we're going to zero it. So, in place of x, x plus h, and then we square that. So, obviously, this means that we've got 2 brackets like that, x plus h. Then we can sort of like start expanding. So we know that we're going to have x squared plus 2 xh plus h squared, right? H squared. But we also know that, okay, f of x is just what? Because remember, here it's f of x plus h, and then there's f of x is just x squared. So we've got everything that we need to substitute onto the formula now, okay? So we can go right ahead and say, okay, f prime of x is going to be given by the limit when h approaches 0, and then we substitute f of x plus h. So f of x plus h, right, is going to be given by this x squared plus 2xh plus h squared. Now we're going to subtract f of x, right, which is what? X squared. And then obviously we need to divide throughout by the h over there, by h. So now let's simplify the numerator. So x squared plus 2xh plus h squared. So obviously what's going to happen here is x squared and x squared, they're going to cancel. So we're going to be left with what? 2xh plus h squared. That's what we're left with in the numerator. Okay. So let's go right ahead and then simplify. So obviously this is like an algebraic expression. You can see that there's a common factor here. There's h here, and then there's also h squared there. So h is common. So let's take h out. So the limit when h approaches 0, we take h out, So the reason why we're always going to take out the h because we wanted to cancel out with the h in the denominator. So when h is out, we are left with 2x plus h, and if you multiply throughout with the h, you realize that you'll get exactly that. Okay, so now let's divide throughout by the h. Okay, so there's an h here and an h here. Remember, I spoke about the conditions for cancelling. You need to have one term over one term, and you can see that this is one term. Okay, this is one term. Why? Because this and that are diluted by what? Multiplication. Even in the denominator, you've got one term, so we're ready to cancel. So this cancels with that. So basically, what we're going to be left with, it's this. We're going to be left with the limit when h approaches 0, and then we're left with just 2x plus h. And obviously, this whole thing here means that in place of h, we need to substitute what? 0, right? We need to substitute 0. But we couldn't do that before this step, right? We couldn't do that because if you had substituted 0 in place of h at that point there, you get an undefined answer. Why? Because in mathematics, we're not allowed to divide by 0. So that's why we had to simplify in such a way that eventually we cancel out this h in the denominator. Okay, so okay, this is the situation that we have here. So now to get rid of this, we simply substitute 0 in place of h. So we're going to have 2x plus, in place of h, substitute what? 0. And this is what? 2x, which is the same as the value that we got. All right, so the value that we got when we're using differentiation rules. Okay, so that's how you use your rules. Your first principles to differentiate. So let's look at a slightly different problem. Well, we're just going to change our f of x, or maybe let's say we are now having g of x, right? G of x is equals to x cubed plus let's just say maybe x. Okay, x cubed plus x, right? This is going to be a bit challenging, but let's try it out. So now that means our formula is going to be, okay, g prime of x is equal to the limit when h approaches 0, right, of what? Of g of x plus h minus g of x divided by what? By h. So let's find g of x plus h, which is going to be x plus h cubed, and then plus x plus h. All right, so let's start simplifying that quickly. So obviously we're going to have x squared plus 2xh, right, plus h squared, right, times x plus h. Remember, this represents what? X plus h squared. So I sort of like split the x cubed into x squared times x plus h. So yeah, and then we add our x plus h. So now this becomes what? We need to multiply throughout with the x plus h now. So we're going to have x cubed plus 2x squared h plus x h squared, right, and then plus x squared h, and then plus 2x h squared, right, plus h cubed, right, and then plus x plus h. So that's what we have over there. So now you can go right ahead and see if we don't have any like terms. X cubed is just going to remain like that. So 2x squared h, and this, so this, and that's a like term. So we've got plus 3x squared h, right, and then plus x and h squared, so we've got this, so that's plus 3x h squared, and then let's see what else we've got. So that's pretty much it, h cubed plus x plus h. So you can see that now there's quite a lot of algebra that we're applying. Okay, yeah, and then we know that our g of x is simply x cubed plus x. This is literally the most difficult part, just simplifying after substituting your x plus h, right? So now to find our g prime of x, that's easy. We're just going to substitute whatever that we have. So the limit when h approaches 0, and then of g of x plus h. So g of x plus h, we know it's this whole expression over there. So we've got x cubed plus 3x squared h plus right, x squared h plus 3x h squared plus h cubed plus x plus h, and then we subtract what? We subtract g of x, which is x cubed plus x, right? And then we divide throughout by the h. Okay, so the problem is almost done. So now what we need to do is, okay, limit when h approaches 0. So we just don't do, okay, x cubed and x cubed, they cancel out, right? This x and that x, they also cancel out. So basically what we're going to be left with is 3x squared, 3x squared h, right? 3x squared h plus 3x h squared plus h cubed plus h. Remember, this cancelled with the x, and the x cubed cancelled with this x cubed over there. So everything is now divided by what? It's still divided by the h. So let's go right ahead and factorize. So the limit when h approaches 0, right, of we take out the h. So h out, you will see that now we're left with 3x squared plus 3xh plus h squared plus 1, right? That's my camera right now, right? So it's plus 1, and then we divide everything by what? By the h. So this h and that h, they cancel. So basically we're left with what? We're left with the limit when h approaches 0, right, of what? 3x squared plus 3xh plus h squared plus 1. So remember, this whole thing means that in place of h, you substitute what? 0. So we're going to say, okay, fine, let's do exactly that. We've got 3x squared plus 3x and then h 0 plus h squared 0 squared plus 1. So our answer becomes 3x squared plus 1. And even if you use the rules of differentiation, you get the same answer. So g of x is equal to x, right, x cubed plus x. So we know that it's going to be g prime of x. Using the rules, it's 3x squared. We multiply with the 3 minus 1 there. And then this one, the exponent is 1. So 1 times 1, that's just 1. And then 1 minus 1 is 0. So our answer is like this, x, 1 minus 1. So that's 3x squared plus 1. Because, I mean, x to the 0, that's just 1. So you can see that we're getting the exact same answer. So our answer is correct. And that's it, ladies and gentlemen. Don't forget to like, comment, subscribe, and also share with the people that you think might find the video helpful. So shout out.